Let's say I have some x-axis starting at 0 with tick marks at 1 and 2. On these points, we have a proton and an electron. What is the acceleration on the electron due to the Coulomb force of the proton? To solve for acceleration, we can use Newton's second law, which states that force is equal to mass times acceleration. We can rewrite this in terms of acceleration to yield force divided by mass. Now, the mass of the electron is known to be 9.109 into 10 to the minus 31 kilograms, so this is not an issue to figure out. However, we also need the force, which we can find using Coulomb's law. Coulomb's law states that F equals kq1 q2 by r squared. We can substitute in k, and writing the units on the axis can determine the distance r to be 1 meter squared. As this is a proton and an electron, we know that the charge of the proton is simply the elementary charge 1.602 into 10 to the minus 19 coulombs times negative 1.602 into 10 to the minus 19 coulombs, since one is a proton and one is an electron. Plugging this into a calculator yields a force of negative 2.307 into 10 to the minus 28 newtons. Now to solve for the acceleration, we plug back in the force and the mass. And calculate an acceleration of negative 253.2 meters per second squared. As the sign of the force was negative, this is an attractive force, which means that the acceleration will also be towards the left.